Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present my final year project session 2021-22. First of all, I would like to introduce myself. My name is Abdul Aziz bin Jusoh. My supervisor is Dr. Roselina Binti Roseley. Today our panelist is Dr. Amalina Binti Amir as a panel number 1 and Dr. Natasha Binti Ahmad Nawawi as panel number 2. My final year project title is Investigation of Tribological Behavior for Nickel Graphene Oxide Composite Coating Effect of Temperature. Today agenda presentation is number 1, Introduction about the project, number 2, Project Methodology, number 3, Result and Discussion, and lastly, Conclusion and Recommendation. Before I go to introduction, I would like to explain the problem statement. Friction coefficient, contact between surface, contact pressure, frictional force, and other factors influence the tribological performance of material. And several studies has been conducted to identify the influencing parameters and their impact on overall tribological performance with or without coating. The purpose of this work is to investigate the tribological properties of nickel graphene oxide composite coating. To overcome the problems, the objectives have been met. Number 1, to fabricate nickel graphene oxide coating on mild steel at different deposition. Number 2 is to study the tribological behavior of nickel graphene composite coating. For the introduction, tribology is the analysis of friction wear and lubrication on moving surface. Tribology can be contribute to the energy efficiency cost of industry. Nickel graphene oxide was used as a coating for this study. The tribological behavior of nickel graphene oxide composite nano coating were analyzed using pin-on-disc tribometer. Methodology for this study is: number 1, preparation of substrate. A rectangular mild steel was used as a substrate as shown in figure number 1. 4 samples were grinded and polished using grit sandpaper 120, then 180, then 320, 600 and ended with 1200. The surface roughness were measured using Alicona infinite focus and tabulate data in the table number 1. As you can see here, sample number 4 had the lowest surface roughness among the other samples. Next is preparation of electrolyte for the electrode deposition. Graphene oxide was dissolved in 1 liter deionized water and ultrasonated in ultrasonic bath for 2 hours and mixed the nickel sulfate, boric acid, ascorbic acid and saccharin powder. Table 2 show the bath composition. After that, electrode deposition process. The variable of experiment is the temperature of electrolyte, which are 35 degrees Celsius, 45 degrees Celsius, 55 degrees Celsius and 65 degrees Celsius. The steady speed is 300 rpm with constant current 2 ampere for 45 minutes. Table 3 show the electrode deposition parameters. Sample number 1 used to 35 degrees Celsius, sample number 2 45 degrees Celsius, sample number 3 55 degrees Celsius and sample number 4 is 65 degrees Celsius. Next is characterization technique. Number 1, micro hardness of coating. We are using Vickers micro hardness test machine with load 1 kg force. Second, chemical composition of coating. To analyze the structure pattern of the coated particle with the range angle 2 theta from 30 degree to 100 degree. Surface roughness of coating. Alicona infinite focus were used to quantify the surface roughness of the coating sample. Lastly is tribological test. Pin on this magnet TE-165-SPOD was used for the tribological testing. All the samples were tested for 20 minutes at a rotation speed of 250 rpm. As you can see in table 4, is the pin on this parameter, which is applied 10 Newton. Test duration for 20 minutes. Speed is 250 rpm. Pin diameter is 8 mm. Thread radius is 10 mm. And sliding distance is 314.159 meter. Figures 2 show the substrate of the pin on this test. Next, we move to result and discussion. Hardness of coating. 3 different spots on coated surface were measured to find the micro hardness and tabulate in table number 5. Control sample has micro hardness value 204.2, sample number 1 266.5, sample number 2 274.8, sample number 3 352.8, sample number 4 357.7. According to figure 3, sample number 1 had the lowest micro hardness of 266.5 Hv, while sample number 4 had the highest micro hardness of 357.7 Hv. Based on the result, the hardness of coating seems to be increased with deposition temperature. Next is chemical composition of coating. Overlapping between graphene and nickel at 44.8 degree for sample number 1 in figure 4a. Sample 2 in figure 4b has an overlapping graphene and nickel at 44.7 degree, whereas sample 3 in figure 4c has an overlapping graphene and nickel at 44.6 degree. The graphene and nickel overlap at 44.7 degree in figure 4d. That is surface roughness of coating. Each coating average will compute by taking the average of 3 points. Table number 6 shows the surface roughness of the coating for all samples. Data from table 6 were plotted in graph in figure 5. The sample 3 had the average highest surface roughness, which is 2.09 micrometer, while sample 2 had the lowest surface roughness at value 1.1 micrometer. The result revealed that the increase the deposition temperature may slightly rise the surface roughness of deposition nickel graphene oxide coatings. For the thickness of coating, sample 1 has the highest coating thickness of 13.24 micrometer. The thickness of coating has reduced to more than half when the deposition temperature increased to 45 degrees Celsius before slightly increased at temperature of 55 degrees Celsius and reduced again at temperature of 65 degrees Celsius. Table 7 shows the thickness of coating every sample. Data from table 7 were plotted in figure 6. The result indicates that deposition temperature of nickel graphene oxide coating has considerably influenced the thickness of coating. The temperature of nickel graphene solution does not much effect on coating of the sample. Friction coefficient. Sample 4 has the highest coefficient of friction, while sample 1 has the lowest coefficient of friction of all, as shown in figure 7. Compared to bare sample without coating, the friction coefficient of all nickel graphene oxide composite coating was lower, as shown in figure 8. The graphene layer inside the nickel graphene composite strongly reduced friction, where of the sliding contact. And lastly, for wear test, sample 4 has the lowest wear because of the higher micro hardness it has, which is 357.7 HV, while sample 2 has the higher wear because of the thin thickness of nickel graphene composite coating as shown in figure 9. Figure 10 shows the sample for lost just 0.0196 gram, whereas control lost the most weight 0.2132 gram with difference of 0.1936 gram when compared to sample 4. Sample 1 lost 0.0972 gram with a difference of 0.776 gram. Sample 2 and 3 has losses of 0.1821 gram and 0.1547 gram respectively. Sample 2 has the largest percentage weight loss of 0.31%. Sample 1, Sample 3, and Sample 4 had weight loss of 0.29%, 0.16%, 0.26%, and 0.03% respectively. The coating of sample 4 had the best wear resistance of friction, as shown in figure 11. For the conclusion, the electrode deposition process has been used to successfully fabricate nickel graphene oxide composite coating at deposition temperature of 35 degrees Celsius, 45 degrees Celsius, 55 degrees Celsius, and 65 degrees Celsius. The results show the increase in the deposition temperature enhance the micro hardness and increase the surface roughness of nickel graphene oxide composite coating. Sample 4, which had deposit at temperature of 65 degrees Celsius, has the highest friction coefficient of 0.92. It has the lowest wear when compared to other samples. Sample 1 recorded the lowest friction coefficient of 0.43. The outcome of this work suggested that the higher the sample micro hardness, the lower wear rate. For the recommendation, we can use titanium electrode to create superior coating on the substrate. 2. Utilize an automated surface grinder to have a better surface roughness for deposition process. And 3. Wait until the solution of nickel graphene cool down at room temperature after the ultrasonic bath to start deposition process. Lastly, Raman spectroscopy analysis may be used to investigate the wear on coating to predict the wear mechanism of coating. That's all from me. Thank you for your time. If you have any questions, you can call or WhatsApp me at 014-534-9382 or email me at abd.aziz5767@gmail.com. Thank you so much. Stay safe. Bye.